5.2 says prove the identity. So when we have an identity, we usually want this side to be equal to the other side. And what you can do is you can work from the more complicated side since it has more things that you can control. So here I'm going to work with the left hand side. So my left hand side will be equal to minus 2 sine squared x plus cos x plus 1. This is all over 1 minus cos 540 minus x, like that. Then we need to obviously reduce some things and convert some identities. Sine squared x has its own identity, and that identity is 1 minus cos square x. So let's try that out. Usually these identity problems are a problem of trial and error. You try one identity, it doesn't work, you erase it, you look for another one. So here I'm putting 1 minus cos square x, which is the standard identity for 1. I will show you just now. So we have sine square x plus cos square x is equals to 1. Make sine square x subject to the formula, and you get sine square x is equals to 1 minus cos square x, which is the substitution I just made. Then I'll say plus cos x plus 1. See, I'm trying to just move around because I have an idea of what my final thing should be. It should be something that has to do with cos x. So I'll try to convert as many things as I can to cos x. Now, when this is done, I can move on to the bottom part, the denominator. And the denominator in this case is 1 minus cos 540 minus x. Now, I obviously have to do something about this 540 minus x. I cannot see any 540 over there. So in order to reduce this, it's important to note that 540 is just if you were to draw your Cartesian plane, it's 360 degrees, and this would be something like this. So from here to here is 360 degrees. If you were to go again for the second round and add 90, so adding 90, that would give you 450. If you add another 90, you'd have 550. So 540 is the equivalent of going around. Let's start off small. It will be the equivalent of this. So we start off like that. We go 360 here. We go 540. See, that was not supposed to happen. We go 360 here. We go 450 here. Plus another 90. We go 540 over here. Now this is 540. And if we're saying 540 minus x, so 540 minus x, that would be in this quadrant, somewhere in the second quadrant. And we know cos is, so all students take. Students here represents sine. Only sine is positive in this quadrant, and we have cos landing in that quadrant, which means this will be negative. So besides this minus that's already there, we're going to put a minus cos x. And this is what we have so far. So I'm gonna now simplify this by multiplying by minus 2 inside. So minus 2 plus 2 cos square x plus cos x, and minus 1. Well, plus 1 minus 2, that's going to be minus 1, but I'll put the plus 1 for now and put this all over 1 plus cos x, because a minus and a minus gives us a positive. Now this is what we have so far, and this is what we're trying to get to, 2 cos x minus 1. So let me simplify this. 1 minus 2, that gives us minus 1. So this is technically what we have now. And as you can see, you have a cos square and a cos x. Generally, people don't see that this is a trinomial up here because they're not used to working with a variable that is cos x, because cos x isn't a general variable. Rather, I encourage students to make some kind of substitution at this point. So if you say let cos x be represented by any variable, you can even represent it with x, which is something you're familiar with, or you can represent it with k, if you're familiar with the k method, if that's what you call it. So making this substitution will give you this 2k squared plus k minus 1 all over 1 plus k. Now this simplifies it a bit. As you can see, we've replaced all instances of cos x with k. And then now we can clearly see that this is a trinomial. And at this point, you can either use your quadratic formula to find the values, but in this case, you're not solving for k, which might become an issue if you're not really sure how to use your quadratic formula in this instance. In this instance, what I would say is try to use some intuition. You know that this should be your final answer. So if we were to rewrite the right-hand side in terms of k, it would be 2k minus 1. Now, at this point, I know that that's what I'm trying to get at the end. I'm trying to get the right-hand side. I'm trying to get that 2k minus 1. That means here, this has to be broken up in such a way that we have two brackets in which one of them is 2k minus 1. So you could try and be cheeky, if you can recognize this and use that this will be 2k minus 1 and this will be 1 plus k, or k plus 1. But also you could actually try out that method. So solving for this trinomial or factorizing this trinomial, which has a coefficient of k squared that is non-1. So it is a value that is greater than 1, in this case 2. Generally, it's a trial and error method. You try and think about it. So here, I know I'm going to need a 2k, as 2k times k gives me 2k squared. Then for the rest, you look for factors of 1 that you can use, add to get positive 1, and then feel around the question to see how you can get a positive 2k, a positive 1k over here. So positive 1k, that can result from 2k minus k, which means this would have to be multiplied by a negative 1. So in here, I can put a 2k minus 1. And then here, I can put a plus 1 and see how this pans out. So this will be 2k times k, gives me 2k squared. 2k times positive 1, that's positive 2k. Minus 1 times k, that's negative k. So we have 2k minus k, that gives us positive k. And that's what we have. Then lastly, minus 1 times 1 gives us minus 1. So we can see this is a correct factorization. If you were to use the longer method, which would be the quadratic formula, depending on how fast you can type on your calculator, then the values you would have gotten would have been k is equals to a half or k is equals to 1. But you can refactor or re-engineer these two brackets from this. By multiplying both sides by 2 here, you'd have 2k is equals to 1. And over here, you can take k to the other side. You'd have k minus 1 is equals to 0. That will be one of the values. And move the 1 to the other side. You have 2k. This should have been minus 1. So that it goes here and becomes positive 1 to 2k minus 1 to that side. You have 0. So you have both of these brackets that you otherwise have already gotten here. So here we have 1 plus k and k plus 1. The order doesn't matter. These are like terms. We cancel them out. And then we are left with 2k minus 1, which is equal to our right-hand side. But, if you want, you can now take out the k and make it 2 cos x minus 1, because we know k was representing cos x. And as you can see, your identity has been proved.